Hi all, welcome back to my YouTube channel. So today we will discuss more detail about the RDD in the Spark. So let's start. RDD stand for Resilience Distributed Data Set. It's the fundamental building block of Apache Spark. So let's break down into this detail. So how it will work, we'll understand in this and what are the key feature. So in this like resilience. So what is resilience? We'll understand here in the technical and the simple word also. If a node or a computer in the Spark can compute lost data using lineage information. So the lineage information means whatever the activity it will be performed. So it will be get created the path kind of the thing. So it will be remember that so what we previously did and it will be lost data, it will be recaptured. So how it will work? Simple term. Like suppose image you have the list of the tasks and if you lose one, you can look back at your original to-do list and rewrite that lost list. Means like the what RDD, like the from one RDD, whatever the original RDD it is there, it will create the one will do the transformation so that it will get created the new RDD. So all these like so suppose the new RDD it is get lost. So understanding the previous RDD and so that data we can recover and whenever we will the every transformation will happen. So in that like the lineage graph or like the lineage the path it will be get created. So that's why like if you lost anything it will be recollected. So that's why it is resilience. So the simple example we have given here, like suppose copy 1 2 3, this is the one task and in this like suppose if you lost the tree like the as you see in the below 1 2 and it is lost the tree, create using original list, we can create that and this is the how it will happen using the lineage. So distributed. So in the RDD, the first is resilience. So what we understand here. So if anything is lost, it can be regained that. So in the distributed. So how distributed will work here? In the technical explanation, we'll understand. So if the data it is split into the part and stored on the different node or the computer in the cluster. So whatever the data file we have in the from the source, what will the distributed. So what we'll do here, like the data will be get distributed across the node or the computer. So it will be distributed. It is not like the one file will be stored in the one place. So the below one of the example we have given here. So understand in the simple words, like think of having the list of chore that you divide among the friends. Each friends handle their part, making the process faster. Because if the one person is handle everything, it will take time. So that's why it will be get divided. So, like suppose the laundry, dishes, and the vacuum and the grocery. So these are the list we have. And so what we'll do, how it will be get divided? Node one, laundry, node two, or the computer two, dishes, node three, vacuum, and node four, grocery. So like this, it will be get divided. So that's why it will be distributed. And the next one is the data set. So technical explanation like the what is the data set in the RDD? RDD is the collection of the data element like the row in a table. It's not like the table, but just it is the row in a table means one row. Like this, the RDD it will be get created. Okay, and it is distributed across the cluster. Imagine like you have a grocery list and it will be split into different people, the part of the people. So how it will be understand here, let's see like the grocery list, we have the fruits, we have vegetable, and we have the dairy product. So fruit will be get distributed to the one computer, vegetable to the another, and the dairy to the next one. So like this, so whatever the we have this the list and it will be distributed to the every computer. So that's the one the data set it will work. So we'll understand some of the properties kind of the things of the RDD. So RDD is the immutable, means once the RDD is created, it cannot be changed. Transformation create the new RDD instead of modifying the original one. So the original previous whatever the data we have, from that data it will be get created new RDD if you're doing any transformation, but original RDD it will be the remain same. We can't change that. It is just a read only kind of the things. Okay. The simple example like suppose think if you have a pen and you are writing on the notebook, if you want to change something whatever you have already written, so instead of like erasing that and it is not erasable, so we will be take the new page instead of erasing, so that's the new page, that's the new identity, it will be get created. So like this it will be work, so that's why it is immutable. So like the original RDD, here we have given the example 1 2 3 4 5, and we are doing the map transformation, and when the new identity it will create it, so this one, so original identity remain unchanged. So this is the data it is changed, sorry it is the remain unchanged, and it is not changed only, so it is look like the similar. So what is the next property? So we can understand parallel processing. As we know the distribution data, so data it is processed at the same time across the multiple nodes of the computer to speed up the computation. So data it will be like parallelly processed. So it is divided into different computer node and it will be parallelly processed. So this is the way the parallelism of the processing it will be work. And so we'll understand here this the next things is a simple example on this, like suppose assembly in a factory where each worker perform a specific task simultaneously. Which in the factory we have a lot of workers, so each worker will be assigned the one task and they will work independently and the parallelly. So that's the way that we can finish the work faster. So the example here, understand the data A, B, C, D, E, and each computer it's like the working on the each task. So the node 1, node 2 up to node 5 we have provided. It is the parallelism. So what is the next property of the RDD? It is the in-memory computation. So whatever the computation is, whatever the task it will perform, it is in the in-memory. It is not in the disk. So the RDD stored intermediate results in the memory rather than the disk or on disk to faster process. Because if any data will store in the disk, it will be take more time to process. If it is the in memory, it will be faster. Like suppose if you remember, you take the example of your phone book and you have that immediately, so you can dial that. That's the in memory kind of the thing. And the recent list of the phone book. And if you want to be it is doesn't have the recent list, then you have to search in your phone notebook, so that's it will take time, right? So this is the way it is the in memory example it will be work. So the one more example we have given in the written, so suppose you are doing some calculation whiteboard ram, instead of writing them into the notebook, it's quickly erasable update in the whiteboard. Okay, so visualization, some of the calculation intermediate memory how it will work. So the results like the faster, quicker will be available. And the type safety. Next property of the RDD is the type safety. So what is that? So the type safety means that operation on the RDD are checked at compile time to prevent type error. Means like suppose take the example like think the spelling check in the word process, it's catch the mistake before you print out. Means like suppose you are written something word in the notebook or in the word pad, and so you are giving the print, so before printing it will like alert you or it will check the error, so if there is any mistake, so that's the type safety. So that's the one of the things, the properties available here. Okay, so next jump into the the transformation. So in the action example like the resilience. So we have created the RDD, the Spark content, and parallelism we have given like the list 1, 2, 3, 4, 5. And so this is the RDD we have created and how it will be get distributed. So this RDD is the means the one RDD it is created, it will be not get changed. It is read only kind of the things and how it will be get distributed. So here the RDD we have created and the we have distributed here. Okay. So this RDD has a three partition. We have given the three partition and it is divided that. And so the data set. So how it will be looked for the RDD? RDD is the collection of the data element. So we have given here the one of the example, the Bob, Alice, and the Cathy. So their age. So that's like one of the example of the data set. So it is not the tabular format. Okay. So like this, the RDD will work. And as we said, it is the immutable, means it is one is RDD is written, it will cannot be changed, and the next RDD it will be get created. One of the example like the we have written here, the RDD we have created for this, and we are doing the map operation here. So once we create the new RDD, the previous RDD, this RDD is remain same, but the original RDD it will be get created top of that, and when we show the RDD, the results will be like display. So that's all about the RDD. Thank you. So we'll understand what are the advantages of the RDD. So RDD it can be recover lost data if the computer fail or the node fail. It means like the lineage transformation. So what is the lineage transformation? So like it is the information or like the metadata kind of the things, the information from the life cycle of the data movement, like the from source to destination or the from one RDD to the next RDD. So what are the things is happening? So it will be create the entire the flow flow chart or the flow diagram kind of the things, means it will be remember what happening from the each steps, what are the transformation is happening. So that's if it is a fail, it will be recover using the lineage transformation. Okay. So distributed data is split and processed across the mini computer at once. Okay, it is distributed and parallel processing. Whatever the data it will be there, so it will process parallelly. So it will be quickly by using the multiple computer. Okay, in memory. So store the temporary data in memory for faster access. And it is one of the example is like the type safety. Check the data type during the code to avoid the error. Okay, so means the during the coding itself, the we can check the error of the code. So that are the advantages. And what is the disadvantages? The complex is required more code and understanding how the distribution system work. So it is the complex process. Less optimized, not as fast as other Spark tool like the data frame, which have the built-in optimization. Means when we come to the data frame, we'll understand that lots of like the optimization method it is automated, but it is not there. Here we have to tell each part optimization. We have to write everything. So how it have to be work in the RDD. Why use the RDD? So why we have to use? When we need to precise control over the data processing and you are dealing with the structure and the various data. So the RDD, one of the things it will be limited to the some what we call the language. So it is not support some of the language like the Java SQLite will support, but it will not support the Python. That's also we have to be understand. And where we should not use the RDD when we use the data frame or the data set for the simpler, faster operation. So we should not use the RDD. Okay. So limitation. So the more detailed code is needed for the compared to the data frame. So that's the limitation. We have less optimization compared to the data frame. And the in-memory management manually how to be managed, store the key things smoothly. So is a lot of things is being manageable required. So in the summary, if you conclude that RDD as the backbone of the Apache Spark, provide the robust framework to distribute the data processing. They offer resilience, distributed processing, and the fault tolerance. That's the main property of the RDD we can understand, but come with needs to be more code, understand the distribution computing because it is the older version, the first version of the data frame. So that's why. So the whatever the things we have to be right, we have to tell to the RDD like how it have to be work, the optimization method we have to be right. So that's the tricky one. So let's catch you to the next tech video. If you have any doubt, thank you.